This is Escondido, Sunday the 22nd of September 1985, and we're taking instruction from Dr. Stephan Riess, an eminent earth scientist, at his home in Escondido, high on a rock promontory overlooking the valley and showing massive protrusions of granite boulders all around. Stephan Riess is a very controversial scientist and has extensive knowledge worldwide in the finding of water. Do you have any immediate finds in Escondido in the last 3 or 4 months?
Yes, we've been successful in drilling some very good wells, and it happens that both locations are on the highest parts in the county, 1,000 feet higher than the pump stations for the water supply from the Water Resources Department. And the cost of pumping it from there, these stations, the river water from Sacramento up into these reservoirs here, is $93 an acre foot in power bills.
And poor quality water?
And it's poor quality water, yes. So the point now is that these water wells can produce the water for $20 pumping cost instead of $93 to lift it from the pipeline below up on the surface.
With no carrying of silt or anything of that nature?
No, it's clean water.
And the water here is very pure water, isn't it?
It's exceptionally good. It's usually about 1/3 of the mineral content of the prevailing Colorado River water.
And this is because of the fact that you're extracting primary water from very deep?
This is because it's primary water obtained below the crust and is in the non-oxidizing zone.
So this is not being oxidized?
No.
And it's not picking up contaminants?
It does not dissolve or pick up any contaminants, and therefore it's superior water. It does not need any more cleaning or pre-treatment for the distribution system.
And you don't have any, or very little if any, radiation?
Well, there may be fast dissolving radon, which is about 1 day lifetime in the water in the reservoir.
And radon would not be a real factor here?
No, it's no factor at all.
Because its decay is so rapid?
Right now. And in itself it's not very serious.
But it wouldn't be anywhere near like the contaminants that could be picked up as a result of surface testing of nuclear weapons?
Naturally not. That is, of course, the point. When they're talking about claiming waters, bad waters, which are already bad at the origin from the faucet, and then going to the industrial and whatever uses there are, and then go through the sewage lines and retreating is absolute insanity.
Yes. Not necessary because of
It's
the technology
ridiculous.
that you've developed.
An article in the paper I got here before me today is talking about treating 200 million gallons of sewage for reuse. Now who in the devil would want to use sewage water again?
When it's unnecessary.
Absolutely unnecessary.
And your water supplies literally are limitless.
Naturally they are limitless. They claim that the water is from the surface seeped in over long periods of time into the rock structure. Itself an impossibility. Absolutely.
It couldn't go down through impervious rock.
Neither nor below the zone of oxidization. The pressure there is too high for water to continue. Rock is twice the pressure or the weight from water itself.
Sure.
And water it's incompressible, absolutely incompressible. Rock is more compressible than water. This is the standard knowledge that we have had for a long time.
Incompressibility of water has been known for many years.
That's why it is used in the industries for pressure checking. And to talk about reclaiming water from sewage use for public demand, why, it's ridiculous. It's a
And unnecessary.
Absolutely unnecessary. Absolutely.
So that the water, even the best water that can be obtained out of the water cycle, is by all standards poor grade water related to the water that you're finding below the surface of this granite.
That's right. Once the rainwater hits the ground, it immediately starts to absorb contaminants.
All the soluble elements that can be absorbed will be absorbed into it.
Always.
And all of the contaminants that the precipitation washes out of the atmosphere on the way down through to the earth.
Absolutely, absolutely. And accumulate.
And accumulate.
That is the rub of it.
Now, as a health matter for public and personal health, water is absolutely an essential ingredient to good health, isn't it?
Well, not only that, but for the existence of life on the planet, whether it's animal life, human life, or vegetation.
But all the water that is on the planet at the moment and that fills the oceans ultimately or primarily has been generated from the source that you're finding now. Is that not so?
All the water that is now coming to the surface by deep well drilling may be 1 million years underground old.
And the salination and also the complexity of seawater is a result of soluble elements being taken out of surface water and washed into the oceans.
Which had to come into the ocean by a runoff of rain.
Yes.
It couldn't be there any other way.
Yes.
No question about that.
That is referred to generally as cycle water, or water that's gone through the evaporation, the cloud formation, the precipitation, and then the flow back to the ocean via the rivers.
Why science and the teaching today of science has ignored the presence of about 1,500 big wells or springs in the world that go from 10,000 to 200,000 gallons a minute constantly.
Back into antiquity.
And are way back, and are actually 8,000, 7,500, 9,000 feet elevation, usually in the granitic system. It's not explained. We have 2 wells in America, or springs in America. They produce 800 million daily. One is in Missouri and the other is in the desert in western Oregon.
800 million
gallons
per minute.
Right. And
per day,
the one in Oregon, western desert of Oregon, is producing the Day River.
My word.
So where did it come from? If that was rainwater, all the rain in the state of Oregon on an annual precipitation wouldn't flow that spring 1 month a year.
And the river flows 12 months a year.
Yeah, but it's flowing 12 months, yeah.
See, we had talked a little earlier about some of the chemical differentiation and compositions of the rock involved with the specific location of the wells that you've been drilling. Could you elaborate on that a little bit more?
The main thing is, if you study your structure, if you have volcanic debris from the earlier tertiary period maybe, or even earlier, like here in this country, this here is old, 100 to 150 million year old, before it came out of the ocean. There we have contamination produced by the decomposition. The minerals fall apart, they dissolve, whether it's copper, lead, zinc, or whatever the minerals are, aluminum, they get into solution. And then you find them all in the water. Whether it's high chlorine, you get a high chlorinated water. And often so bad, it's absolutely unusable. But in every event, it's very, very damaging to human life, to plant life, and harmful.
You're speaking in terms of groundwater at this point?
Yeah,
as far as
present groundwater. But when you go and consider those very big, deep sources of water, usually coming in as springs on the high mountain systems worldwide, and usually are a lake, and a big lake at times, then we end up dealing with something that could never come from the precipitation cycle, because it just isn't available. Never was. You can't get precipitation water on a steep mountain range more than about 1 inch of water per foot of land. And if you had a 10-inch rain, you have about 10 inches of heavy saturated ground. Then it's all over. There's nothing going down below 20 and 30 feet.
Certainly not through impervious granite
Why not?
5,000 feet thick.
Not even through the soil.
Not even through the clay.
No, couldn't. It's impossible.
So it runs off on the surface and picks up more contamination as it goes.
And out she goes in the ocean, and then that's the damn trouble. That they're getting it here when it's damaged and ruined if they drill it very shallow holes. If that rainwater gets off and gets into the valley to highly porous sand and gravel, of course it sinks. And they call that the water table, which it is.
It sinks to bedrock, but to only the top of the bedrock,
That's
not
all it
below
is,
it.
just a basin. It's basin water, that's all there is to it. And it's accumulated for centuries. Now we are pumping it away at about 9 times the rate
Of its accumulation.
of precipitation. And it's ridiculous. I seen a report here right today in the paper where they're talking about treating 200 million gallons of sewage daily in this county.
Yes, you mentioned that before, and it's
Well, there it
ridiculous.
is in the newspaper.
Okay, as opposed to the system of the groundwater, ground table water, basically.
Yeah.
We were speaking earlier also
Right.
of the water coming from the earth in the form of steam, as you had mentioned,
Right.
Ross. And you had indicated that as this comes in the form of steam, basically it's condensing. It comes up and condenses and comes up through the fractures and fissures
Right.
at that point. Could you elaborate a little more on some of the other chemical changes that occur as the steam is coming up and the water is clearing itself, or
The steam generally reduces 1% of its volume
and-
to a heavy moist condition.
right?
Saturated air.
Heavy saturated. And then it usually is locked in with the metals and the minerals and remains there for an unexplainable length of time. But eventually it's liberated. Because,
the water be liberated.
no, the whole system.
Oh, okay.
Eventually the water will dissolve any substance on this planet,
Right.
no matter what it is.
Everything is soluble.
Everything soluble, or whether it's land, rock, or whatever you
Even
call
gold,
it.
silver, and
Metals and whatever, it'll dissolve it. That's all there is to it. And then you have it in solution. You can analyze the seawater right now and you find practically everything in that we have in the form of solids.
every soluble element is in
Right.
seawater, virtually.
There's no question about that. But on the other hand, if you then recognize that photosynthesis, which is this plant life, the grasses, the trees, everything that's green and living, consumes 600 billion gallons daily, worldwide. That's enough water to empty the last gallon of water in the ocean in less than 3 million years. So what about the rest of it? Ever since the tertiary period, 15, 16 million years ago, the ocean has raised by 1/3 of its total capacity.
As a result of the production of this primary water, which you're now extracting at the surface.
Damn right, it's gradually breaking out and it's showing up. We got I have the record of 915 springs. They go over 10,000 to 200,000 and a larger proportion of them. And some of them go into the millions of gallons daily. And are usually springs on the high points of the mountain range, not in the canyons.
I'm sorry. Have you ever done any analysis of the type of structures, Steve, where these springs are located? As far
Oh,
as
naturally,
chemical
on that
composition?
basis, I'm locating my wells.
Yeah.
If I know the crystallography and the mineralogy, then I know that I can depend on that good water and drill it.
And the crystallography and mineralogy would indicate to you which areas are contiguous with that go into the magma, basically. Where the source
Naturally,
of the
they had
water
to
is.
have the direct source and continuity there.
How does that actually relate, though, as far as, say, if you have a dike?
Yeah.
Maybe you're on a dike coming
Yeah.
out. Are springs usually connected in contiguous?
Well,
sections
generally
with the
always
dike?
on a contact zone,
Okay, on a contact.
whether
zone.
the dike surfaced or not.
Okay.
But it has to be a surface zone. Now the point is, what people ignore, I can go over over 1,000 acres of land, say a whole section, whole mile, on these ranges. And I find variations from 5 to 10 different types over that 1 mile, mineralogically
Okay.
and petrographically.
Right, right.
The ordinary person who doesn't even recognize
Now, are
it.
you talking about surface rock, or are you talking about actual dike structures that connect?
Rock that I know belong there,
Okay.
dike strike.
So you're looking for something that's contiguous
Yeah,
with
not
the,
a float.
with the dike. Right, not a, yeah.
And there I can determine directly whether I have contact or the magma.
Okay. That's the, okay, so you can,
The water has
But-
to come from the magma.
right. But because of the mineralogy and petrology of the dike then,
Yeah.
you can say that this indeed is something that is in contact
And the
with
metals
dike.
contained therein.
Okay.
In analysis, what metals and minerals are involved.
Primarily the sulfide group, like.
Then
the
I
lead
know
sulfide.
that I'm right. And I can dare to drill a well and expect some real good water.
So you're saying then you might have a situation where you've got one dike here, 100 feet away, another dike. The mineralogy would be such different enough
Oh,
that in
completely.
one case there would be water connected with it, in another no water.
Not 100 feet away, right on the other side of the dike.
Do you generally see dikes, you know, in general, would you see like if you got a dike formation here, for example, connected with water, would there generally be dikes very close in proximity to
Yes,
other
various
dikes,
other types.
but not necessarily dikes that are connected with water forming dikes?
No,
Would you call them basically,
mostly not.
could you say like there would be water forming dikes and non-water forming dikes? Would that be an accurate way to describe it or not?
I would say water flowing, containing.
Okay,
The dike itself doesn't have the water.
right, but did at one time or came
They're
from
the
the
carriers.
carriers of it. In other words, okay.
As the mineralization produced the water, as the mineralization intruded, say a pound of copper, a pound of zinc, or whatever it is, might have had millions of gallons of water depositing it. Millions. Read that book from Salzman. We had figured out how many gallons water it takes for 1 pound of
I
borax.
read that. Yeah. It's incredible.
See?
Yeah.
Borax is an unknown element prior to 15 million years ago. And the biggest deposit apparently has been Kramer, Colorado.
California.
There is an old borax mine in China, not amounting to much. But that's tertiary. That's the latest mineralization on this planet.
So if you have a dike then that you feel is a water former because of the rock analysis, the reason that water is still coming today then is that it is still, you feel, in direct contact
Oh,
with
sure,
the magma.
with the magma.
But that would generally be somewhere 1,000 to 2,000 feet down.
20, 50.
But the connection or the contact, what I'm trying to say is, where would you access? How do you know if you've got a dike here with the proper mineralization?
By the debris, what kind of debris is showing on the dike.
Okay. But
That's the mineralogy of it.
I understand that. But once you have that,
Yeah.
how do you decide then, and what is the basic principle that you're going on as to how to get water from that dike or near it?
What is the other side of the dike analyzing? Maybe 10 feet away and I'm out of it. I gotta follow the contact zone, whatever the incline or dip is.
And then you would drill the well, for example, if you've got a dike coming at a 90-degree
Oh, and
strike
I'm
here.
over here drilling. I'm not there.
Okay. So
If the dike shows here, don't mean a damn thing. I gotta get this down here.
Because here is where your fracture zones are.
Right.
That dike is because there was a fracture of the granite plate.
No other way. And then
And
a
the
displacement.
fractures are all in the elbow, not in the tip.
And then it's a displacement.
Yes,
gradually.
and those fractures are allowing that steam, which is creating the water coming up from the magma, to be there at all.
That's the passageway.
That's
The steam is way below. The steam is 5
miles
miles,
below.
10 miles down.
But the steam is the pressure that keeps the water up in those fractures.
Right, right.
The bottom pressure is continuous. This is a continuous process. It doesn't have any end to it, does it?
Now, science is slowly admitting it. There is 28 universities now petitioning the government to put up 8 million immediately to start drilling 15,000-foot holes to capture the steam. The steam means not a damn thing.
But they're saying and admitting that there's steam there as primary steam, but they're
Right.
denying that's primary water. And if I'm not
Naturally.
incorrect, steam is water in another form, is it not?
Naturally, they've
And
denied
you've been
that.
saying this for 40 years?
Since I came out of
Stephen?
school.
You've been now in connection with your work in the mining field,
Yeah.
you found virtually invariably that when you got to a certain depth in these deep mines, that you would hit this water that you're describing,
Right.
and it would flood the mine out.
At that,
That's one case when you didn't want that beautiful potable
that
water
is correct.
because it was destroying the whole operation.
But I learned what to look for not to get caught in it.
Yes, and you learned that that water was perfectly usable because I understand at one time you carried some of it for the camp cook and he was astounded how good the water was.
That is correct. But I had to, on mining, watch out not to get into one of those streaks.
And this is how you found to watch the evidence
minerals.
in the minerals.
And the metals and the content.
And when you got and saw these things, you knew that water was close and you got to be careful.
Under given volcanic debris.
Mhm.
See? Which then is, of course, crystallizing, but not usually very, very crystal, very solid. Usually a rotten stuff. Never really crystallized properly.
Yes, fractured, broken, poor,
Yeah,
weathered,
weathered
weathered material.
You would see this on your cut, on the mine cut.
Oh yes, I can see it right by getting it. Then I know I have a deep-seated fracture.
And on the basis of that, you could frequently sort of go in another direction or stay away from the major water coming up?
Well, once you're down in an area of 4,000, 5,000 feet,
You sort of
the
forget.
water pressure is so goddamn high it comes through the moment you get near it.
Steve, have you ever actually seen water just flowing through these fissures? I mean,
Why, sure.
Actually flowing through?
Oh, sure. Certainly.
You may have this water in there in these fissures up to pressures of 600-700 pounds, 1,000 pounds per square
Yes,
inch,
yes,
with
yes.
the steam pressure pushing it.
No, there's no more steam. That's already too far down
But
below.
the pressure of the steam is still there.
The head is still there, plus the weight of the formation. The weight of the formation is hitting incompressible material.
So
Water.
This is,
So the water being half as heavy as the material that's holding it,
And totally incompressible.
and it's got to come through.
It must be forced through any way that it can be
No
found
matter
out
does-
of the fissures.
The least little crevices and through it goes, and then once it has a runway, it'll dissolve and dissolve and dissolve and
This
make a
is-
larger.
This is the principle of the hydraulic system, isn't it?
Naturally, there's no question about it. There's
The
nobody disputing this.
The instant pressure is put on one end of a hydraulic system, it's instantly at the other end because of the
Absolutely.
incompressibility of the water fluid.
Absolutely, I've seen that water come in so fast it isn't funny.
So when you free that one end, the total pressure that's there is going to flood the area that you
Flood
free.
the whole damn area. I've been drilling into those damn things and pulled the drill rig out on the mine, and the boys pull the rig out and get hit with a heavy spring of water. Right under a high pressure hose, hits them right in the face. A little drill hole.
And continues to come out of there
Never stops.
until the mine is flooded and you can't see it
That's
anymore.
right. Till it found its pressure.
Found its pressure level.
It
When
make-
the weight of the water and the pressure are equal, it stays there.
Now the last big discovery was in Africa in one of the big gold mines I haven't owned stock in. They went from 5,300 feet level to 8,300. Rolled the shaft, went down. Hit the water, out. 87 million gallons a day.
87 million gallons a day.
Yeah. And it came up to 5,000 feet in the mine
And stayed there.
and stayed there. That was the equal of the head behind it.
A 3,000 foot head, a 3,000 foot with pressure.
Yeah, sure.
Equal to the 3,000 foot pressure. The
Yeah,
weight of the water at 3,000 feet.
yeah, it was about 1,400 pound pressure of water.
So this water that you're finding in these deep crevices is continuously trying to seek an equilibrium
That's
with
right.
its pressure.
And if you find it fairly solid in your material, you shoot through. Watch it. You're not far from it. See? If you keep on going, you just lost her. She's bound to come in.
And there's no such a thing as an exhausting of this supply.
No, hell no.
Because it's continuously being born.
It's absolutely impossible there be no water on the planet. At the daily loss of water on this planet by each blade of grass, by every vegetation, everything alive, there'd be no water in the oceans in less than 3 million years. It's all split.
So many years ago, you forecast that the oceans, when they get down to find it and are able to test it, would have massive amounts of potable fresh water
Naturally.
in the bottoms.
I kept telling him that. That's the only source of water we could have.
And now when they go to find the Titanic at 12,800 feet, they're finding just what you said.
Right, and here, the last Scripps Howard expedition there, 12,000 feet in the Pacific, they found a 3-inch spring flowing beautiful fresh water. And a little ways away, a spring, or whatever it is, 700 degrees steam.
Now why is that, Steve? Why does one have fresh water and one have steam?
Different source,
Different source.
different connection, different dike.
Like you had talked about earlier, the different
Right.
dikes. One dike here having a...
My 3 wells in Idaho, in Cottonwood,
Yes.
they are less than 200 feet apart, all 3 of them. And each one has different chemistry. And each one is big well, big flowing water, but not the same water. High class water, but the chemistry is different on each one of them.
So the root of this dike, these different various dikes are going down to,
Right.
they're all connected with magma most likely.
They have to.
Like, I guess what I still don't understand is why one dike here, one a few hundred feet away, going to the same source, would one would be highly sulfide, mineralized hot water, where the
They
other
don't go to the same source. They're different.
The fissures are all different, going
Different
to different
leads.
sources.
They come in on that last extrusion.
You're
Why?
working
So-
with the tops of the fissures.
Right.
And the fissures are at angles, so as they proceed down through these 25 miles, they're miles apart at
Oh
the base.
Lord, yes, that water may come up here on one fissure and its source is over there.
Right.
Or from here and they split away like this.
They split from the top this
Right.
way. Because what you really have is a big chunk of granite that's been fractured like that as a result of volcanic action
Not
and
the
left
gr-
a lot of fissures,
Not the granite.
not the granite.
Granite is seeded volcanic rock.
Ah,
Granite is a crystallized sedimentary, mostly ocean.
ah. So it's not the granite. What is it that's fractured below then?
The basic debris, which is the what we call the plutonic rocks.
Subgranitoid material.
They're way below the granite source. They're below the basalt.
Below
Way
the
down.
basaltic rock.
Yeah. This granite here all was marine sand at one time.
It's unfortunate that we just have to go down through that hard granite to get to these fissures.
Not always.
But sometimes.
Sometimes, no. The wells we drilled here up, that Maya drilled, they never hit the granite.
They never hit the granite.
No. Never. We didn't intend to either. There is a few granite big blocks like this laying on top, but they never were there originally.
So what type of material is it that he's going down through now?
Volcanic debris,
Volcanic
all
debris.
kind of mixture. Analysis, nothing positive. You can't classify it as this or that or the other. It's just a mishmash.
So it's basically, you might say, a volcanic sedimentary that's been there probably for millions of years. And
Over
slowly-
for millions of years.
Volcanic conglomerate.
Conglomerate. But no crystalline structure.
And basically there, for example, where Myers is now, you've intersected the fault lines that connect at a very
The
deep source.
contact
with-
zone,
yeah. Okay, so
And that's where that water is migrating on.
what I still don't understand for sure, Steve, is why if you have this massive fissuring system down there with all these branches basically coming off, where going back to the hydrothermal vents at the bottom of the ocean, why one of these is going to be such good fresh water, another is going to be mineralized.
Come in from a different source. They have a different or outlet.
Okay.
That is not the source there for the water. This one may come from way there. This one half a mile further in. But they are all different and wind up in this outflow structure, which was created by the gases and the volcanism.
They literally converge at the top,
Right.
but they're dispersed at the bottom.
Completely.
And the reason one is a freshwater, potable, drinkable source
Yeah.
is that it depends on which rock formation it goes through,
Naturally.
as opposed to the one that's highly mineralized.
How long it's been locked up and what type of metallic structure. If it's in the water, in the rock with about 500 or 1,000 or 10,000 years, it dissolves the minerals.
So the water you're able to intersect basically is basically It's
Condensed steam originally.
right. I guess what I don't understand is why that condensed steam in some areas it's mineralized, other areas it's not. Where it's not mineralized, the minerals basically precipitate out.
If the steam comes through a highly mineralized fishing, then you got bad water. See?
What would determine that? Well, what kind of, say, highly mineralized fissures? I mean, like
The dissolving of the metal and mineral. The water has a terrific quality of dissection or dissolving.
Right. I understand that. I guess I'm still not clear why some of that water comes out good and some of this so highly mineralized.
Some is fresh flowing and clean. Others is locked up maybe for thousands of years among that metallic structure. So there it is.
The leaching process has had a very long time in which to act,
Oh,
and the
God.
water now is the you've got what we call pregnant water there,
Right.
with the minerals that have leached over these many years.
The last report that came out, they claimed that they now have found water 1 million years old.
Now that'd be sort of like conate water, is that what they call it?
Yeah.
Conate water, where it's been sitting there.
Million
dissolving.
years
And
old.
the water that is good has been deposited in something where the leaching process is either very, very slow indeed, or hardly leaching at all,
No, where you didn't have the metals.
or where you didn't have the metal.
See, the metals do not form at great depth. The metals, like the water itself, are coming slowly in. Not that they come not as a metal.
So they
It's
come,
a transmutation of the elements. And not metal when they started out. It's a constant change, a life cycle of the element itself, which they never considered possible, but now they know it is. This planet is life, everything goes through a cycle like you and I.
the water first then, or the steam, or whatever nature the water happens to be in, leaches out these leachable elements
And
some
transmutes
it, and carries it and then transmutes.
Transmutation,
So it then deposits the metal up again, way up above,
where the pressure resists.
where the pressure resists it.
Right.
And so the metals got there as a result of being carried by water,
No other way.
or steam, or gas of one form
As
or
a
another.
gaseous state.
One form or another.
The outgassing on this planet is unbelievable.
So-
People don't realize that.
Was the water that you found in the mines, Steve, that, fled out these major mines, for example, was
Yeah.
most of that good quality drinking water, or was most of that highly mineralized?
No mineral.
No mineral.
No, when they
Seems
come
to me
in,
that should have been the mineralized water.
when they come in high volume, there is no mineral. They were originally possibly depositing all the metals. See?
But the secondary formation.
The continuation, they were cleaned and there was no more metal coming.
So theoretically, you might generally, would you say in general you would find better quality water in mineralized mining areas as we know them today?
At deep sources, yeah. But not on the surface where it's locked. And the surface, the upper 500 feet, it's got oxygen to keep on working.
The leaching process is accelerated by oxygen in the water.
Dissolve everything, every substance. But when you're way down there is no leaching, there is no possibility. No. It's so simple, that water problem is so damn simple, that while there is a lot yet to be observed and studied and found out, nature has shown us clear, long ago, that the source of water is the depth, not the sky.
Well, after all, 7/10 of the Earth's surface is water
On the surface,
on the surface,
but not the mass.
but the depths of the seas are greater than the depths of the land.
Now wait a minute.
We have sea depths 36,000 feet
Yes, and that's only the crust of the earth.
on top of the crust of the Earth. Higher than Everest is, deeper than
Oh.
Everest is high.
That's right.
And the water that you're speaking of, this primary water, has been filling these massive basins for trillions of years,
Right. And he's still doing it.
and is still doing it. All we're doing then is borrowing a little part of it that went up through the Earth's crust on solid land instead of into the bottom of the ocean.
That's all.
And these waters are continuously being formed by the process of the magma against the materials at the bottom of the Earth's crust.
The cooling of the Earth's interior. The more cooling proceeds, the thicker the crust. We find right today that the high mountain ranges, the crust is shallower than in the deep sea. That's why we call the Andes Mountains, because the lowest known rock formation is andesite. Andes.
Oh, I see, inside rock form, yeah.
And the surface crust there is about 6,000 to 8,000 feet shallower than on the ground here in the lowlands.
The thickness of the crust varies enormously around the Earth's surface.
Yes. But the higher the ranges, the shallower the crust.
Could you elaborate a little bit more on the temperature of the water of the wells because of the fact that they're a little bit higher than normal?
Well, it's very simple. The ground temperature here, right out here, is about 56, 58. Year round, that's the ground temperature. Formation temperature. Now if I drill water and find it 78, means that I had 1,600 feet of depth. You gain 1 degree for every 80 feet.
Every 80 feet you go down, it increases temperature 1 degree.
No matter where the hell you drill.
No matter where on the Earth's surface.
That's right.
1 degree for every 80 feet of depth.
For every 80 feet of depth.
And so when you get 80-degree water, you know how far you are down.
It had to come from down there. You know the surface, which is governed by the climatical condition, sunshine and light and temperature, atmospheric. Say here it's 60, 58, 60s, around there. I haven't looked at the maps. And if I drill here 2,000 feet, what do I get? I get 10 times 8 is 800, isn't it? I get 20 is 1,600. I get 25 degrees higher temperature. So I should get 68, or say 70, I should get 95 degrees. And that usually checks out that way, generally. You go right up there and check an hour wells there, or check Anchopas well. Perfect, 10 degrees, every 800 feet, no question. It's very interesting, all right. As soon as you get the hell down, you gain 1 degree every 80 feet. That's all there's to it.
In the area unaffected by the atmosphere.
Yeah.
Yeah.
The interior heat eventually is getting immense. Of course, you can go down 10 miles.
In the well that you drilled in the Sinai Desert in Israel,
Yeah.
the scientists that were there said that it couldn't be found there, did they not?
Oh, naturally. If it had not been for Ben Gurion giving strict instruction that nobody should question my work or obey or not obey my orders.
Mm-hmm. You would never have found it had not given it.
Never drilled.
So Ben Gurion was the one responsible for making them obey you,
No, they know it too.
and they know it. And you found a well there that produced how many gallons per minute?
Around 4,000. We only pumped about 1,400.
About 1,000 gallons a minute.
Oh, that's what she said on.
Yes. And how deep was that well, Mr. Riess?
1150 or 12, around 12.
11 or 1,200 feet.
Something like that.
No other water well had been found around that area at all. had it?
Oh no, and they drilled a lot of dry holes there.
And the area with water was highly arable, was it not?
No,
The surface area would be highly arable if it had water, which you
close by.
Yes.
But where I drilled the well was a deep rocky canyon.
But close by there was arable land.
There were the big lands which they put into what they call to agriculture.
And as a result of your drilling that well there in Israel and the tremendous publicity that you got for it and from it, they got a hold of you in Saudi Arabia and asked you to go to Saudi Arabia.
That's where the trouble started.
So you were standing with one foot in either camp and finding water for both.
Right, but that's when it started. You see, the Jewish newspaper, the Jerusalem Press, I think that's what they call it. Anyhow, the Jerusalem newspaper came out big 2 pages headline. The luck that they had, you know.
To find that beautiful water
Yeah. But the Arabs could read Hebrew there.
as well.
And the next day, the newspaper in Cairo and everywhere let loose.
And talked about your finding the water.
And the non-Jewish, the Arabs thought, those bastards can't survive. There is no water. They can't make it.
But they could.
Well, naturally.
And of course, Saudi Arabia, as a result of your finds, has done some natural development, has it not?
Well, naturally, but the big trouble was the Jordan River is comes out 16 miles inside Israel
Uh-huh.
and flows about 16 miles into Jordan.
Mhm.
And
So there was a political controversy over that.
So the Jews complained when the Arabs complained, the Jordanians, when they put 500,000 acres into immediate agriculture by taking the Jordan River to flood the country.
Mhm. Stealing or taking the water anyway from Israel.
Then it went into big arguments. Finally, it could only be solved by what they call the court, International Court in Hague.
Mhm.
The Jews had the management under control and somehow paid off or whatever the hell it is, and came in with the statement that they cannot use that well now. It's gone to salt because it's a mile from the Red Sea.
Mhm.
And they made that damn thing stick.
Sure. Yep.
So the ruling by the International Court was 50-50,
Between Jordan and Israel.
right? And they had to let that water roll again.
Did they mention the fact that Jacob's well in Jerusalem had also gone salt at the same time that your
Oh.
well?
They got away with the rawest deal.
Jacob's well went salt when your well went salt,
Right.
isn't it? And the same kind of salinity, like pure water salinity?
Yeah. Oh, they got away with murder.
But they didn't pay you for that, other than your trip over there and back. They didn't
I
pay
had
you for
nothing
it.
to pay for them. I was hired by a bunch of local Jews in Los Angeles.
Yes. Now, you did go to Saudi Arabia, though, and you found water there for them.
Yeah.
And you found water in the mountainous region not far from the
No,
Persian Gulf.
out of their sand dunes and out of their oil
In
fields.
the northern western part, or northern eastern part of Saudi Arabia,
Northeast, yeah.
near the Persian Gulf.
Somewhere up there, yeah.
Over the mountains overlooking the Persian Gulf,
Right.
north of Ras Tanura
That's right.
and south of Abadan.
That's right, south of it. I found good water there, too. No problem. Saudi Arabia has no problem with its land. There's lots of water in the mountain range like here.
Yes,
Beautiful timber.
beautiful timber and potable water that can be transported into the desert regions.
Well, they had to go up there finally and get it in jugs out of springs. There was no more. The springs had gone sour because I suppose they drained it off too fast. And then, what was his name? The crown prince. He became the king later.
Khalid.
Saud.
Huh?
Saud.
He was Faisal, King Faisal.
Faisal.
Yeah,
He
Faisal
was
the
shot
First.
by a native.
King
by-
Faisal the First, yes.
Yeah. Faisal went with me and took me up there.
So you were escorted by the King of Saudi Arabia to this.
Well, there were a lot of phonies with
Yes,
him.
but there were a lot of other sheikhs
Yeah.
and other people.
And
And basically, the king escorted you up there.
right,
Things
and
was
they
quite
had
an
a
honor.
big tank, sort of concrete tank, where the women every morning by daylight used to go down the canyon about 1.5 miles and got their jugs full of water and brought it and dumped it in there. And the women used to come around there, all in, must have been 75, 80 women and families, in other words. They used to come around picking up their water for the household. But to the women there, that was their daily
Sure,
chore and fun,
their recreation.
and to meet and talk and chat. And we had that water going, and I said to the Crown Prince, now you got plenty of money for your oil, you better pipe that water into those houses now. Do away with that unsanitary damn tank. Oh, he said, no. I said, why? He said, that'll be the end of me.
Yeah, very unpopular to get rid of their recreation period.
And he said, if we stop those women from their daily recreation, I'll have a revolution we couldn't win.
And we're seeing that he was right in America at the moment.
Sure he was right.
When America is proving this to be correct, isn't it?
Yeah.
With the revolution that we have with our women here at the moment.
He was right, boy.
Wise
Well,
man.
You see, he had his foot in there. His father, the King's, was in Wiesbaden in sanitarium. It was Saud.
Ibn Saud.
Ibn Saud.
Abdulaziz. Ibn Saud, Saud Abdulaziz.
He had lived in Wiesbaden with about 40, 50 women there, rented the whole damn establishment, and was out of business. So he took over the rule as Crown Prince, and he ordered that the kids can come to school without the little girls without their veils and without that horse shit, and that the girls and the boys can be in the same schoolroom and all. Became very unpopular. See, he broke.
Trying to change custom is a bad thing to do.
Very bad.
And you found this to be so in telling the truth about the deep water that you're finding, that
Not
custom
true.
is killing you.
I'm in the same beat. So he came with me out there because he was so damn interested to lift his people out of their problem.
Yes.
And he spoke damn good English. He was graduated in English.
Oxford, England. Yeah. Oxford.
And he told me, he says, we are just in the state where we are waking up as a country, as a people. It's going to be tough. So,
When you located the water in Saudi Arabia, you said you did it out in the sand dunes out there. Were there any
the mountains.
geographical features that to go by?
well, this was all basin land down here. And that hill over there was the mountain
Oh,
range.
so you could tell from over there where the dikes
And
were.
I went up there and located a water well up in the pine woods, up in the mountain. Which of them was screwy? Naturally, water's supposed to
Fall down to this level.
What general relationship do these dikes have, Steve, say for the areas where it's very dry and so on, and a lot of times you'll see, incredible growths of vegetation and trees and so on. Does it relate to these
That's
dikes?
the deep seated water.
It's just basically percolating.
Sure, hydrogen.
How do you relate that then to location of some of these wells? And do you use that as one of the signs of some of the general areas you would look
Oh,
at?
well, sure, deep seated water. There's 3 times as much water growing vegetation on the country than there is ever deposited by rain. This is only 1/3 of the water they can get. Remember, if we had an inch of rain, it wets that ground 1 foot deep, average.
The soil, it
Yeah.
moistens the soil to one.
That's all it moistens it. It can't go anywhere. There's no more water. It's all absorbed by the soil.
Like a sponge.
A 10-inch rain, which is an awful heavy rain during a month, the worst you get is about 10, 12 feet of soil moisture. No more. They claim that no rain yet has been found to go over 30 feet deep.
They're the maximum penetration in even the very wet areas of the earth.
That's right.
Are
30
only
feet.
about 30 feet.
That's all.
So the idea that the deep water percolated down from the surface water rain is just an absurd suggestion,
Plus the volume.
and the volume. But it would be an absurd suggestion even ignoring the volume, wouldn't it?
It is.
Since it couldn't
It is.
go through that impervious material.
Simply ridiculous.
Impossible.
Simply ridiculous. This paper here saying 200 million gallons down here in San Diego area of sewage daily. Now you multiply that over the population areas. Well, shit, there isn't enough water coming down the river to Sacramento.
If enough of the wells that you're finding were
Yeah.
drilled here, California could be perpetually independent of water being transported from
That-
any other state, could it
That's
not?
what I'm driving at.
Yes, of course.
There's no question. I've got the geological structure to do just that. That's not a problem.
Are you of the opinion that if the politicians had had the final say, the world would still be flat?
I suppose so. Because 90% are nothing but con men that just say yes, yes, because somebody told them to do so.
Yeah. And you know for a fact that all of the billions of dollars that have been spent in bringing water in is merely bringing silt from one place in the country to the other place in the country.
That's right, and make a hell of a lot of money for the big land and ranch
But that's
speculation.
extremely expensive silt, isn't it?
Yeah,
But now the water that's in those canals that are being brought down from the Colorado River is continuously deteriorating water because it's picking up soluble elements out of the surface as it comes along, isn't it?
no question.
At a much more accelerated rate because the sun or the solar heat is accelerating that precipitation, isn't it?
And because that water is running in open canals without any concrete bottom,
Yes.
40-50% seeps away on the way.
40%,
Well,
a lot.
that's what they claim, 40 to 50%.
And some of it is being taken off the top in
And
evaporation.
then, of course, evaporation, naturally. There is no question about
So the
that.
evaporation alone would make that water poorer quality.
Yes. Now, the whole thing is absolute childish. If it wasn't for the greed of some people, ignoring the welfare of anybody and everything, we wouldn't be in such a mess. If we had politicians with any brought up intelligence or education or being made aware of, it couldn't happen.
Anyway, your experience has shown you that you have to go on your own and not be influenced by political opinions anyway, and you're simply producing beautiful, clear, potable water out of 2,000 feet below the Earth's surface, water that could only come from the source that you've identified many years ago.
Found in the mines.
And in fact, you now have beautiful, potable water, regardless of what the scientists, the engineers, or the politicians are
don't mean
saying.
a damn thing.
It's very hard for them to refute the fact
They
that your
have to.
theories are good when they find your water the way it is, isn't it?
But that bunch of legislature, 8 out of 10, wouldn't know what you're talking about on water. They just, I told you, you'd vote yes, whatever side they're on.
Maybe they would be better able to help you if it were whiskey that you were finding,
Oh, they would, sure. Providing they found a market for it.
providing they found them. Or all that they could not consume themselves that they could find a market for.
You know, you have to marvel about the welfare of society being so damn insecure when you come right down to it.
Yes, indeed.
Extremely insecure. We see that now, right now in Mexico today. You take those high-rise in Los Angeles and New York, 101 story, when they collapse, there is no chance to get in and find anybody in a month's time. There's a pile of rubble there.
Yes. So
And
our society is very fragile and
Oh, yes.
delicately balanced.
And many of those high-rises have 10 and 15,000 people working in there every day.
So if the earthquake happens during the middle of a working day,
You find nobody
no one
on
would
that
be-
big stuff. Because the pile of rubble was so high, you can't get in, start digging or do anything.
Yeah.
And the water systems are destroyed in natural
And the gas line break
disasters of that nature.
underground.
And so the availability of your water would be there regardless of whether earthquakes occurred or not.
That's right.
And it would even be there if nuclear testing in Russia was accelerated.
Wouldn't hurt us.
It wouldn't change your water quality at all, would it?
No.
So
never.
we might survive being in the western side of Russia's test area simply because of this beautiful potable water that you're
What-
able to produce.
What they don't kill off by the explosive threat.
Yes, but I mean, we are the recipient of all the fallout
right.
from Russia's experiments because we're on the western side of the experiments.
We get the least of it.
Yes,
It's going east. The natural currents,
the upper air currents are flowing
east,
east,
going east.
but we're east of Russia,
I know that.
and so we're getting a lot of their test fallout, aren't we?
No,
We're not?
no, it would have to come around first.
Ah,
See, anything from here goes over the Atlantic and across. When they had that damn trouble here with the
That's never done the atomic testing out the
Right.
islands out there.
Russia got the works. They had over 22,000 dead there.
Because of the high altitude currents.
From Asia, northern Siberia is going to get the big part of it.
In the event of nuclear explosions, this water would remain safe and potable.
Oh, naturally. What's left wouldn't have anything to worry. That water is always good, and the only water that could possibly be contaminated is the lake.
Surface water.
The springs they form.
And reservoirs.
The reservoirs. But you never heard the deep water. Never reach it.
Radiation can't penetrate that deep
No,
through
it
that.
doesn't go that deep.
Are you able to connect up the early days of your life when you went and saw those wells along the castles overlooking the Rhine River? And
Well, that's when I woke up as a youngster about his age.
Mhm.
See, it impressed me, that's all. I realized that it took these people 50 and 80 years digging.
And they were digging down through solid granite,
No, usually everything, like
conglomerate. And
absolute resilicification of original sedimentation. They had a lot of that. Granite a lot, yes.
But very solid material, and they were digging
right.
down through it.
Right.
And so here there was those wells were dug hundreds of years ago, and they're still very, very.
Well, the first one started digging about 930
930, 80,
under Charlemagne.
no, about 1,000 years ago.
Just about 1,000 years ago.
And they've been and the wells are still completely usable and
Absolutely.
excellent water.
One of the most recent ones was in Edinburgh,
Scotland.
yeah, where the Queen Elizabeth Castle up there.
Yes, Edinburgh Castle.
That went down about 1,500.
High on a solid rock
Basalt,
promontory.
just a basalt. And around is the saltwater, high tide and low tide water.
Not affecting it at all. How deep is that, 1,500 feet?
No, about 11, 12 I
11
heard.
or 1,200 feet. Down below, well below the surface of the salt
Oh,
water.
way below. The salt water is just a deep marsh. A marsh, they call it. Very, very shallow. Couldn't get a deep ship in there either, just boats. No.
It's been an hour.
The water business has to change like a religion, and that's hard.
Yes,
That
because
is
his
hard.
deep-seated beliefs are deeper than the water, in fact.
On the other hand, I begin to see where we cut through the wall. The need for water is to our advantage.
Yes.
Or we wouldn't have a leg to stand on.
Yes, like our need for good air and
Right.
good food.
If it wasn't for the absolute need, the worry of running out, they would spend billions to put sewage treatment in. Everything. But that isn't enough.
The water that's being used, the surface water that's being used
Yeah.
in parts of the California agricultural regions
Yeah.
is collecting soluble elements at such a rate
Too much, sure.
that, and also the sprays that are being put on it are being
It's
absorbed
ruining,
into the
it's
water.
ruining agriculture.
And the agricultural areas themselves are being destroyed because of this poor grade surface
And ruin
water.
it. A certain area, I understand, the grapes went sour. They had to get rid of them.
Yes, and in another area they were letting the outflow from the fields, which they flooded to irrigate them, flow into a marsh, and all of the life in the marsh was destroyed.
That's right.
So as you predicted, the surface water is not improving, but getting worse and worse as time goes on.
Bound to.
And
because
your water is getting better and better because it
See,
doesn't have any contamination
we are
in it at all.
washing the damn thing over, and every time cycling it, it gets dirtier.
One of the solutions that the Department of Water and Power has in the report that I showed you that we got recently, this is a long-term plan that some of the Department of Water and Power is planning on to avoid some of the water shortages that they've got. They want to bring in excess water and store it in the, like you had discussed the other
The
day, in the
existing
wells
wells.
up in San Fernando Valley.
Yes.
Well, it seems to me that, you're just going to be contaminating all that water that you're bringing in and putting in the wells.
Because the wells are being contaminated. all
Oh,
the time.
sure. The whole thing is silly. It's absolutely silly. We either got to stop wasting on using the population to finish it up too fast, or slow down agriculture completely. so
The
low.
wells that you did for California City, which are still hammering away there,
Oh, full blast.
full blast, which is now what, almost 20 years ago, over
More.
20 years ago, over 20 years ago. Those wells were producing beautiful potable water,
They still are.
and still are.
Yeah.
Before you drilled those wells in there, they told you there was no water available at all, did they not?
Well, not only that, they prevented the California City Company for selling any land or do any building for 5 years.
Because of lack of water.
The lack of water. Because there were no pipeline. You see, they let him fool around for 2 years with the city of Los Angeles, the metropolitan water, to get it cut in on that line coming down from Bishop. Well, they played around too. The lawyers had a hell of a good time, I suppose, for a couple of years, meeting after meeting after meeting. Nothing happened. Then we went and approached the water resources, and they said no, they wouldn't bring any water in from the Bakersfield area over there, what they call that, Tehachapi country.
Tehachapi country.
They couldn't afford it. There is not enough demand or income from it.
It wasn't economically feasible.
That's right. Then I shoved that hole down. I drilled 5, 6 wells there, and then I put a big one down where the government had said the test wells to them had proven an impossibility. And that was right out in the center there, where the lake is now,
Yeah.
the golf course.
Yeah.
And
How could you have made that lake without water?
Well, naturally, they admitted that. But then, of course, it lasted for about 6 months. Oh, it'll pump off, you got a small pocket, yo. So I argued with the bastards up in the water resources, they sent me up there, and I said, you goddamn well know that locked-in water, closed-in water, would immediately disintegrate by the absorption of all and the destruction of all the mineral constituents. Well, yeah, but there is a lot of it there, and you'll get that pretty quick. So nothing happens there. Then after 5 years, they went and sued him, brought a suit in the courts. They figured there'd be too much publicity on this. And
So they dropped it.
They dropped it and gave him a permit to start selling lots, building homes, and what have you.
They didn't want to go into court and admit that they'd been wrong, that you hadn't pumped out all your water in 5 years, and still 15 years later you're still pumping water.
That's correct, and we had water to waste. I had 3 wells then on the tap, going up, one a waterfall and lake, and the other 2 for residential and house use and whatever there was.
What quality was that water?
First class,
First class.
very high class water.
And still is very good.
It still is, and it had him baffled. And they're baffled yet, because it's against their religion.
Maybe they started baffled, do you think?
Well, they were naturally stupid, but the point is that this upset him more. See?
But it doesn't upset you to think that they were wrong.
No, I must look. No, I knew they would be. Hell, what's a me? It's like you and I trying to convert to one of those fanatic Muslims today.
Yeah.
That's ready to drive an automobile with 500-pound explosives into a gate or somewhere.
There are none so blind as those that will not see.
That's right.
And you have shown these people that in addition to the bumblebee, which theoretically cannot fly,
That's right.
Stephan Riess can find water where there is no water.
That's right.
But the water is there and it's flowing, and Stephan Riess did find it.
Did I ever give you a report from Jerusalem?
No, I've never seen that report, but you've told me about the well.
I've got a
He's
copy.
got
of
it.
this. Yeah, I can get it
Copy
to
the
you.
report. You had 1,000 gallons a minute in those wells.
Oh, yeah.
But you feel that it was entirely a political thing on the Jordan River that made them deny the fact that the
Well,
water
they had
was
to.
there. Yes. Well,
You see.
they felt they had to. They felt they had to not tell the truth about it. But then it was too late, wasn't it?
No,
Because
they had to tell half story. They had to tell
not the whole truth.
not the whole truth. They had to tell the wells are bad and they're dependent upon.
But it was too late, wasn't it? Because they'd already publicized it all over the country, and it had gotten as far away as Saudi Arabia.
But several years later, they admitted in the United Nations meeting at The Hague in Holland that the wells have gone to saltwater. intrusion from the Dead Sea,
Uh-huh.
or Red Sea,
Red Sea. Oh,
which 2 years ago, a lawyer in
Low.
Washington
Wasn't it Low?
Low,
I think it was Low that was there.
went and investigated and saw the editor of the newspaper who used to be a newspaper man in Washington at one time. And they told him the whole story.
political influence can do terrible things to the truth and reality. Now, you're continuing, although you independently found it, you're continuing a theory that was started by a Swedish scientist many, many years ago, who was also nominated for a Nobel Prize.
Yeah, but he died before. He drilled 17 holes on the offshore islands where the lighthouses were, starting in solid
On the coast of
granite.
Sweden.
And in that country they had a big problem to keep water from freezing in the winter times. So he drilled those wells and he invariably hid water in the granite. Now they were small little 4-inch and 6-inch holes, but he proved the water there.
And proved this theory of the
And the
primary
continuity
water.
and the type of water, see? Well, what happened, the Swedish scientist, who was one of the highest ranking geologists in his day, his father was the superintendent of the mines in Finland that were mining ore from under the ocean beds.
Aha.
And they had fresh water under the ocean in the iron mine. See?
Again, proving the theory.
So his father kept arguing with him. He said, now how can we get fresh water
Under the ocean surface.
under the ocean surface? Where does it come from? And then Nordenskjöld was his name. He began to use his brain power and got to working it over, you know.
He was dead before you developed your science.
He died in 1904.
1904, yes. So many years before you began.
Oh, I know nothing. Hell, I was born in 98.
In 1898. Yes. So the theory is still as good today as it was
Naturally.
then, because that hasn't changed.
See what happened when we got finally to negotiate the damn thing and got to arguing. Salzman, the professor teaching at that time in Los Angeles, wrote that book with me. He followed me for about 2 years and the wells I drilled all over. I didn't know I had that damn many till lately checking.
800 and some odd wells
Yeah.
around how many countries? Over 50 countries in the world.
Somewhere like that. Yeah. So he came to that information by having 2 students from Norway at his class.
Do the research for it.
Yeah, and one of them came and said, oh, I read about one of our old-timer geologists. He was of that same opinion and there's a book out on him. He brought the book in and
From Nordskjöld.
they translated it. He was a North Pole geologist, very famous for his North Pole work. So, there you are.